Tonight's lesson is lesson 2.4 on rotations. So, a rotation or a turn is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure rotates is the angle of rotation. In a rotation, the original figure and its image are congruent. So, again, we're hearing that congruent word. We're not changing the size or the shape, we're just changing the placement. So here you can see that they've taken the red image and turned it clockwise. So just like we would go around the clock versus counterclockwise, the opposite direction. So they have turned this red image clockwise, so to the right, about the center of the rotation, and we have turned 90 degrees. You can see that they've made a 90-degree angle. So we would say they've turned a 90-degree clockwise turn to make the new image. So let's take a look at a few of these. So which piece is a 90-degree counterclockwise rotation about point P? So we're rotating this piece around this point in a counterclockwise motion. So again, we're going to be going counterclockwise. So in an image like this, it might be helpful to sketch what the piece might look like because we're going to need to pick from these four options. So when we do that, we can see that we have an open, a straight, and two outer pieces. So when we turn this way, each item is going to turn one direction around. So my flat is going to move to my right. Then I'm still going to have an outward piece, and my open is going to move to the bottom. Now we needed 90 degrees counterclockwise, so that's 1/4 of a turn. So now my image would need to look like this. So I'm looking for an open at the bottom, an outward on the left and the top, and a straight side on the outside. So we can see that that is going to match which item. So we can see here that that's going to match image C. So image C is the 90-degree counterclockwise rotation. Now, for question number 2, is choice D a rotation of the original puzzle piece? If not, what kind of transformation does the image show? So let's see here. This would be a 90-degree turn. If we went to a 180-degree turn, my open would now be towards the center. I'd have an outward on the bottom and the left, and I'd have a flat on the top. Now, if I did this again, my flat would move to the left, an outward on the bottom and the right, and an open at the top. So does part D look anything like these four sketches? When we have the outward piece on the left and the top, we can see that my open was at the bottom. So this is not a rotation. So D is not a rotation. So we need to decide what transformation is letter D. So if we look at the original image, it's not a slide because our outward piece is moving from the right to the left. So we know it's not a slide, it's not a rotation, so it must be a reflection. Now, if we kind of sketch our reflection here, we can see that this is a reflection from the original image. For example 3, it says a triangle has vertices Q of 4, 5, R of 4, 0, and S of 1, 0. They're going to ask us to make two new images using rotations. I want you to plot the original triangle right now. Now that I've plotted my original triangle, part A tells me to rotate the triangle 90 degrees counterclockwise about the origin. So counterclockwise, of course, we're turning to the left. 90 degrees means 1/4 turn. About the origin means that's the point where we're going to keep in the center. So we can see that letter S is 1 away from the origin. So we're going to move 1 away from the origin and make that S prime. Now, from S prime, or from S, we see that R is 1, 2, 3 blocks away. So starting from S prime, we're going to move 1, 2, 3 blocks away to make R prime. And we can connect those. Now remember, quarter turn going to the left. So starting from R, we need to be going this direction for Q. So 1, 2, 3, 4, 5 blocks to get Q prime. Now we can connect these points with our straight lines. And this will be the first image. We've rotated a quarter turn around that origin. Now, for part B, it says rotate counterclockwise rotate the triangle 180 degrees about the vertex S. So we're going to keep S in the exact same place, and we're going to do a 180-degree turn. Now, what you should know about a 180-degree turn is 180 degrees makes a straight line. So it does not matter if you turn to the right or to the left, you're going to end up in the same position because we're making a straight line. So I'm going to turn to the right, so clockwise. So my S is going to stay the same. So we're going to call this S double prime. Now, R is 3 spots away. So 3 this way would be a 90 degree. 1, 2, 3 spots this way would be an 180 degree. So this would be R double prime. Now, from Q, moving down here would be a 90 degree. Moving this way would be 180 degrees. We know that 1, 2, 3, 4, 5 spots away from R is Q. So we're going 5 spots away to make Q double prime. So what we really need to think about is once we've drawn the new images, if I picked up the original image, the black triangle, and turned it 2 times 180 degrees, would it make this image? And it would. Now part C, are they congruent? Have we changed the shape? Have we changed the size? Since we have not changed the shape or the size, they are congruent. Here again with number 4, you're going to need to go ahead and draw these original vertices of the triangle on your graph. With number 4, it's giving us 2 steps of transformation. So it says first to rotate the triangle 180 degrees about vertex R. So again, 2 90-degree turns to get to 180. So R will stay in the same place. So R prime. Q goes up from R and then it goes over from R. So 1, 2, 3 spots. So here we would have Q prime. Then P goes 2 away from Q. So P prime here, we can connect those points, and that will give us our rotation. So we went up and around, so a 90, a 180. Again, you could have went counterclockwise, a 90 and then a 180 about the point R. So we're spinning it or rotating it without picking up the R vertex. So you have to think about that being pinned to your picture and not moving. Now we need to reflect it in the in the X axis. So we're going to reflect it across the X. So since R and Q are already on the axis, they will stay the same. So here we will have R double prime, Q double prime, which I know is a little hard to see here, but we'll have those in the same spot. And then P will flip over 2 spots away from Q. So P double prime. So here, now we've drawn our rotation, we've drawn our reflection. What are the coordinates of the new image? So our double prime, our final image. So we have P double prime is at 5, 2. Left and right first, then up and down. Q double prime is at 5, 0. 5 to the right, didn't go up and down at all. R double prime is at 2, 0. These are the ordered pairs or the coordinates of the final image. Here on example 5, it says, describe a different sequence of transformations in which the blue figure is the image of the red figure. So it's saying you're starting with the red and moving to the blue. So how could we get there? Now, there are a lot of different answers that we could do. So I would have said that we rotated 90 degrees clockwise. So if I rotate 90 degrees clockwise, I'm going to end up looking like this. Ooh. Let's see here. Give me 1 second to erase and draw my rotation on here. All right, so I have drawn a 90-degree clockwise rotation to start with. So I rotated my red image 90 degrees clockwise. Now, in order to get to my blue image, I would have to translate 1, 2, 3, 4 to the right and 1 up. So then I could say that I would translate 4 right and 1 up. Now I would have to translate each of my ordered pairs or each of my coordinates to get to the blue image. Try and see if you can come up with another option to get from the red to the blue. On this final example, we're going to be rotating 270 degrees counterclockwise about the origin. So that's going to be 3/4 of a full turn. So go ahead and plot the 4 coordinates on your graph now. Now, knowing that we're going to go 270 degrees counterclockwise means that we should end up in the top left quadrant. So 90, 180, 270 degrees of that rotation. So as we do this, we're going about the origin. So X is at -2, -2. So we're going to move X to 2, 2. So this is going to be my first part of my rotation. Here I'm at -6, -2. So I'm going to move to -6, +2. So keeping that straight line, the longer side, against my axis. Now, Along my axis here for y, I'm at -2, -6. So I'm going to go to 6, -2. And then 3 away from y is my z. Now, when I connect my lines, I can see that I have rotated my trapezoid 90 degrees counterclockwise. I need to keep going again to be 180 degrees counterclockwise about that origin. So again, 2, 2, -2, so we're going to go to 2, +2, then across to 6, +2, so x and x and w. Then from x, I'm going up to 6 or to 2, 6 for my y. And then to 6, -5 was my z, so I'm going to go to 5, 6 for z here. So again, I can see that I've rotated this again, another 90 degrees counterclockwise, so now I'm at 90, 180. Now I'm going to go the one final time to end up with the 270 degrees. So 2, 2 goes to -2, 2. So this will be my final image of x, x prime. Then 6, 2 goes to -2, 6, w prime. Away from my x will be y prime. And then here I will have z prime. So I can have my final image of my trapezoid. So I have rotated 270 degrees counterclockwise. Now, as you look from the original to the final image, if we would move clockwise, so to the right, what degree rotation would this be? Since we would be moving one turn to the right, this would also be considered a 90-degree clockwise turn. So 270 degrees counterclockwise or 90 degrees clockwise.